chapter 5F on Wednesday, so I have to review homework from that. This was almost a day.
Okay.
There we go. So, 31. Alright, let me find one that I...
Let's see, I have your book, don't I? Don't we have the same book?
Yeah, I don't know if it's the exact same edition, but we do have the same book.
What page are you on?
442.
442?
Yeah. It's the first page of chapter 5 review exercises.
Okay. At the top of that page in my book is problem 47. That's not the same with yours?
No, it starts at 1 of the review exercises in there for me.
Okay, and 1 is, what is an extraneous solution?
1 is approximate your value, 3 decimals, which is 6.1 to 2.4.
Okay. What? Mine is 7.6. Is that yours?
No, I'm in chapter 5.
Really? Okay. Chapter 5 what? Our books are considerably different, I guess.
Yeah, they are. So, this is like at the end of chapter 5 when it has like a review for all of the parts of chapter 5. That's why.
Okay, my chapter 5 is like completing the square. Is that the same as yours?
No.
Okay. Why don't you just read the problems to me and we'll do them.
Yeah. Okay. So, this is a word problem.
Okay.
On the day a person was born, a deposit of $60,000 was made in a trust fund that pays 8.75% interest compounded continuously. And then find it on the person's 35th birthday. And then that's that day.
All right. So what's your general formula? You always want to start out problems with the general equation.
If this is continuously, then it would be A per. So A equals P e to the RT.
Okay. So P is what? In other words, let's fill in what we know at this point.
Yeah. 50,000 E. And then
What's R?
the 0.0875
times 35.
Yeah.
Okay. And notice that there are no variables here except the one on the left. In other words, you can get that answer out of your calculator.
Yeah.
You know how to do that?
Yeah, I know how to do these ones. Let me skip forward and look at ones I would struggle with.
Okay. I wouldn't mind seeing an answer on this just to check its ballpark. It should be a pretty big number. It should be like 500,000 or 1 million.
Yeah, I actually just left my calculator just down the hall, so let me grab that.
Okay. Notice one thing here. R is R. It's not 1 plus R. In other words, in your other two ways of doing exponentials, r is always added to 1 or subtracted from 1. But when you're using a equals pert, continuous compounding, then r is whatever decimal it is.
Yeah, so for this, I got 1,069,047 and 14 cents.
Okay. That matches my ballpark estimate. In other words, in 35 years, if you can actually make 8.75% money or return on your money, it grows. It increased by a factor of 20, going from 50,000 to 1 million. All right. What are some of the ones you had some problems with?
Okay, all right. So radioactive decay, here's the different word problem.
Okay.
The half-life of a radioactive uranium-2, and then in parentheses, it's 200 U to the 234, is 250,000 years.
Okay.
What percent is present of radioactive uranium-2 will remain after 5,000 years?
Okay. Now, when you have decay, they use a negative sign. We don't know what K is, or I don't know, what does your school do? Does it still use R?
For these, I think it's A equals C e to the KT.
Yeah, and it's a negative K. If you know, and I'm not quite sure why that is, because you're going to get the right answer whether you put a negative sign in front of that or not. I've always kind of puzzled as to why they use a negative sign for decay, but they do, and it doesn't hurt anything. Okay? So when you have these half-life problems, that means that I can write the following. I can write 1/2 P on the left equals P e to the minus K times 250,000. Okay? And notice that the P's divide out, which is going to let me solve for K. Okay, so now I have 1/2 after dividing both sides by P. How do you solve that equation for K? E is just a number.
You have to bring in the ln.
Natural log. That's the natural log function. In other words, we're going to take the natural log of both sides of this equation. So I'm going to do the natural log of the left, the natural log of the right. Now, what does the right become?
Natural log of a half equals negative 250,000 K.
Yeah. In other words, what you're really doing is you're taking this exponent and you're bringing it and putting it on the number line like that, not the number line, the algebra line, and then multiplying it by natural log of e, which is 1. And so that leaves that exponent. And on this side, we have this. So the answer then to solve for K is to divide both sides by minus 250,000. that's going to be equal to k.
Yeah.
And once you get that number out of your calculator, and incidentally the numerator is going to be negative. Whenever you take logs of numbers between 0 and 1, you get negative answers. But we're dividing by a negative. So my k is going to end up being a positive number, which is fine because now once we solve for k, and you don't actually have to turn that into a decimal at this point. In fact, let's not. Because the moment you turn that into a decimal, you're making it less accurate. Okay?
Yeah,
well, now let's write the specific equation, which is to say the amount I'm going to have is going to be the amount I started with times e to the minus, and k is natural log of 1/2 divided by minus 250,000, all times t. And now I can use this specific formula on any amount of material. Where'd this number 5,000 come from? Oh, how much are you going to have left at the end of 5,000 years?
Yeah.
Okay. Did they actually give you a starting amount? You don't really need it, but I would think they gave it to you.
It says the half-life of radioactive uranium is 250,000 years.
Okay.
What percent of present amount of radioactive uranium remain after 5,000 years?
Okay. So they didn't give it to you, which is fine because you don't really need it. They want to know what percentage. Okay. So if I pretend, the easiest way to do this is pretend that you started with 100. Okay?
Yeah.
And then whatever you get for A, you'll be able to figure out what percent of 100 that is, right?
Yeah.
Okay. So let's do that. So A is now equal to 100 times this, and T is 5,000. So again, you're going to get a specific number when you plug that into your calculator. We have nothing but numbers. In other words, 100, and then E is a number, that's a number, that's a number. So you're going to end up with an A. Let's say you end up with 90 grams or pounds or whatever you want to call it, doesn't matter. Well, then I've got 90%, right?
Yeah, where did the 100 come from?
Just made it up. I could have used 1,000, I could have used 10, I could have used any number. Because what this is going to tell us is if I started with 100 and at the end of 5,000 years I've got 90, well then I got 90%, and there's your answer.
Then you find the difference.
Not the difference. They wanted to know, oh, do they ask what percentage was lost?
They ask, no, it's what will remain.
Then 90% would be the answer. If A came out to be 90. I don't know what it's going to come out to be. You want to do that in your calculator quick? That's kind of hard to do in the calculator. In other words, it's difficult. You have an Inspire?
Sorry?
Do you have an Inspire or a TI-84?
I have a TI-84.
It's particularly hard to do in the TI-84. You just got to make sure all your parentheses are in place and everything else. But to come up with a number. So there's another way you can kind of do it if you have trouble putting all of that in as one function. And that's to do it piecewise. In other words, do indeed come up with a number, How many decimal places do they want you to round off your answer to?
It doesn't say.
Okay. Well,
So I plugged in that number for K.
uh-huh.
And then times it by 5,000.
Okay.
And then did E to what I had in my calculator.
Okay.
Would that be the answer?
Well, times 100. In other words, you got to put in the 100.
And then I have 101.395.
That can't be true, right? That doesn't fit our ballpark.
Yeah.
So let's go back and figure out what's going on. What'd you get for natural log of 1/2 divided by minus 250,000?
Natural log of 1/2
divided by minus 250,000.
2.7725, and it keeps going e to the -6. So there's a bunch of zeros in front.
So in other words, what I'm writing here on the upper right, that's, now you're going to multiply that negative 2.77 times 5,000. Make sure it's a negative 2.77. See, that's why yours increased, is because you were taking it to a positive power. Must have really increased big time, because when you put a negative sign over there, that's going to be 1 over e to the 10,000th power. So you see what I've written in the upper right here?
Well, if you do ln to the 1/2, you get a negative number.
Right, and we're dividing by minus 250,000, which gives us a positive number now.
Yeah.
And then we have the leading negative. In other words, that's why that negative is in the decay general formula.
Then why are we dividing by a negative 250,000?
Well, because if we go back and solve this equation, remember when we wrote this equation here that I'm pointing out? Here, let me put a square around it. I put the negative there because 250,000 was t, but there's a negative sign in front of the k, so it becomes minus 250,000 k.
Yeah, so that's what I don't understand is then we put that in again, so we're using that same negative twice.
No, hold on. No, we're not. Not if you think about it here. Start from right here. Okay?
Okay.
Now, once we've taken the natural log of both sides, we get natural log of 1/2 equals minus 250,000 k.
Yeah.
Now we divide by minus, we got to divide by its coefficient. That's minus 250,000. Okay?
Yeah,
now that gives you a positive number, what I just circled.
Yeah.
Now we're going to put that positive number in for k. Well, if we go back and come up with the specific equation, this k is going to be a positive number, but it still has the minus sign in front of it. We always have to leave that in there. So when you've solved for k, you still have a minus sign. You're always going to get a positive k, but when you go to make the specific equation for this uranium, this particular material, it's always going to be decreasing.
So couldn't we have just kept the negative out of there completely?
Yeah, I agree totally. I have never understood why they put the negative in there, because had I not used the negative sign in the original general equation, then I would end up with a negative k, correct? Yeah.
Yes,
So it's the
I
same
think
thing.
that was confusing.
It's the same
Yeah,
thing.
that's
I don't know why.
confusing.
I don't know why they do it. It seems to me like they don't need to do it. They could use one general equation for growth and the same general equation for decay. But they don't do it.
I don't even think my teacher taught us this with the negative.
Well, maybe she didn't. I had to kind of self-correct myself a couple of years ago because I used to not use it either. Because you got the correct answer, whether you use the negative or you don't. You get the same answers. I think, I'm not sure why math books put the negative in there, but if I open my pre-calc book up right now, it'll have a negative KT.
Yeah.
But like I said, it doesn't matter. If you use the negative, then you got to use it throughout the whole problem. If you don't use the negative, then K becomes negative. And then you'll still end up with a negative. So it doesn't matter to the solution.
I'm putting it in with the negative this time.
Okay. We have one problem, Max, and I do have a 6 o'clock appointment tonight online.
Yeah.
So I'm not going to be able to stay with you more than another minute here.
That's cool. I think I have another one tomorrow.
Yes, you do, for sure. But yeah, I suspect we know that it takes 250,000 years to lose half of its mass, right? So in only 5,000, what is it, 96%?
98.6, yeah.
98.6, huh? Person's average temperature. Interesting. Okay, so that's how much you're left with. And as to whether you want to use 100, doesn't really matter. You could use 1 as that coefficient. And you'd have gotten an answer of 0.986 instead of 98.6. Any number you put here is going to tell you what percentage of the material is left, right?
Yeah, I just left it at 1. So
yeah, that's fine. Then your answer is going to be 0.986, which is still 98.6% of the material is left.
All
right. All right. Max, I'll let you go, and I'll talk to you tomorrow.
Yeah, see you tomorrow.
Okay, bye-bye.